going. I'm Justin Keene.
And I'm Jeffery Ng.
And our project was to build using an accelerometer, build a speedometer for a car. So, what we have is an accelerometer. It's 3 axes, and it's an analog sensor, which means it just outputs a voltage. So in order to translate that, we used an A to D converter, which takes in an analog voltage and outputs a digital number. And we used a microblaze processor synthesized on a Nexus 2 board to do all that. And so the acceleration comes in as just a random number, and we had to figure out how to translate that to an actual acceleration with units. And so once we did that, to get the velocity, we used a summation of a bunch of accelerations at a very high frequency. And using that, we were able to calculate velocity and display it on there. And to test this, Jeff will talk about that.
So when testing this device, after we calibrated all the accelerations and everything, we basically got into Justin's car and we drove around in the Poly Canyon's parking lot. Our first test, we took it pretty slow, and as you can see, our blue line is our observed velocity, which was me in the passenger side looking at the meter on the car, and the recorded accelerometer velocity. As you can see, the blue line is short. We only drove up to about 20 miles per hour, then we stopped recording. For our second test, we decided to record a little bit further than 20 miles per hour. We set the peak at 25. And as you can see, our observed and our accelerometer matched pretty close to each other. So we decided to bump it up to 30 a little bit more, see if it evens out more. And at 30 miles per hour, we can see that our accelerometer matches our observed velocity pretty closely. And we did a fourth test to confirm our observations, and again, it matches pretty smoothly. So we decided to do a fifth test, and we decided to get on the highway and see how far we can go. So we tested it at 60 miles an hour, and as you can see, as we accelerated, our accelerometer followed the velocity very closely.
There was a little bit of error because depending on how the accelerometer is oriented, we actually picked up some gravity, which is just a constant acceleration down. So unless it's perfectly level, we have some error, and so that's kind of why it seems to go up. Like we were going slightly uphill as we were going up the highway. So we accumulated some error, but it matched pretty closely, and we were pretty surprised by that result. So we were expecting a lot more error.
Cool, thanks.